Hi, this is Mr. Nakauchi here, and we're going to be talking about simplifying radicals or square roots because they're going to be coming up a lot in a topic called quadratic formula. All right, so you're going to see them a lot. So we're going to talk about something that's your square root. Sometimes we call it a radical. And square root of 4 is probably something you just remember from middle school, right? It's just 2, right? And we could also do, say, the square root of 9, and that equals 3. And that is a square root. And most of those are pretty straightforward. The problem gets to when we do things like the square root of 8. That gets a little trickier, and we're going to run into things like that on the quadratic formula. So the question is, how do we deal with the square root of 8? And that's going to be called simplifying. Now, there are kind of two ways to do this. And the first way is kind of the way that we're not going to use, but I can't lie. You could just use a calculator, right? Just use a calculator, and you would get that the square root of 8 is approximately, that's what's an approximation, 2.8. The decimal goes on and the decimal goes on forever. We don't have time to write the whole thing. But because that goes on forever, we just rounded a decimal. That's not what we call an exact answer. Right? We don't want a rounded off answer. We want something exact. So we're not going to really use that very much, even though that's what the calculator tells us. So here's how we're going to simplify. We have to look for something that I've given a funny name to. I call them magic numbers. And everything in the highlighted yellow list is a magic number. And that's how we did this. 4 is a magic number of this list because 4 is 2 squared. Right? Because square roots are looking for these magic numbers. 9 is on this list, it's 3 squared. If I'd done the square root of 81, that'd be 9 because that's 9 squared. Notice number 8 doesn't show up on this list. But what we have to do is ask ourselves, well, let's think, what kind of numbers multiply to 8? And I would say actually there's a lot of numbers that multiply to 8, but I'm going to pick 4 times 2. 4 times 2 is 8. All right, actually that's kind of mostly it, or 2 times 4 or 4 times 2, either way. Now the reason I do that is I look for these magic numbers, and the reason I call them magic numbers is because they can transform like a magician. They can kind of, like a lady into a tiger, they transform. Well, the numbers, these numbers under a square root transform into just this without the exponent. So 4 transforms into a 2. The square root of 9, 9 under square root transforms into 3. And so here, this 4 right here, that is one of my magic numbers. This 4 becomes a 2. Now, when it transforms, it moves what I call outside of the radical. So far, I have a 2 on the outside of the radical. And now this 2 here that I boxed, that's not a magic number on my list. And if it's not a magic number in this list, it's pretty much just stuck, staying what I call inside the radical. All right. For radicals, I have this part called the inside. I call that part the inside of a radical, and this part in front is the outside of a radical. Right? And inside, think of radicals like an umbrella. Inside numbers are under the umbrella and outside numbers are not. So this 2 is inside and this 2 is outside. You have one of each. Now always check your inside number, and if there's anything else that multiplies to that, you want to look to see if there's any magic numbers hidden inside 2. Now some people are like, there's a 2 there, but the 2 is the magic number, not a magic number. Only these numbers are. So this is it. This is as far as that goes. Okay, let's do just a couple more examples like that. Let's simplify, okay, because this is how usually all these problems go. Let's simplify the square root of 12, because I'm going to pick numbers that are not directly on this magic list. Square root of 12 is not a number on this list. We got 16, we got 9, but that's not on there. So let's think about what are numbers that multiply to 12. Now this is your brain thinking. It's like, well, there's 2 times 6. But 2 times 6 is a problem because the numbers 2 or 6, we're trying to find numbers that are on this list. So while 2 and 6 are 12, they're not helpful. Is there anything else? Actually, there is. 3 times 4. And 4 is good because 4 shows up on my magic list. So the square root of 12 is 4 times 3. And just like before, the 4 is magic. It magically transforms and moves outside and becomes a 2. And it's not there anymore. And this 3, there's nothing magic about 3, so it just stays inside, and my final answer is 2 root 3 is my final answer. Okay? Another sample, let's simplify the square root of 18. 18 is not a magic number. Are there numbers that multiply to 18? This time I would say it's 9 times 2. And 9 is a magic number on my list. It magically transforms into a 3, and it moves outside. The 2 is not magic, so it stays inside. And so my final answer is the 3 on the outside, root 2. Now there are some rare cases where we can move everything outside, and actually the rare cases are when they are magic numbers. 4 is the only magic number, so if everything moves outside, their square root disappears. That's why it's also magic. If there's something left over, it's got to hang around, okay? All right, just a couple more sample problems. Simplify the square root of 50. Okay, so we have to ask ourselves, 50 is not a magic, look, 49's on there. Close, but close is no cigar. Yeah, it's still not a magic number. And it can't be like, I'll just add 1 or minus 1. Nope, has to be like that. But are there any magic numbers hidden inside 50? They're hidden if they're factors. And it does turn out that 25 times 2, you just have to kind of sit there and think about that. Think about the numbers on this list and ask, are any of them hidden inside? Hidden inside means they're a factor. And 25 isn't 25. It's a magic number, and it becomes a 5 when you move it outside. 2 is not magic, so it's 5 root 2. Okay? Now, next level up, we'll level up. Let's simplify 3 times the square root of 20. All right, now this time there's already a number on the outside of this square root, all right? This can happen sometimes. How do you simplify that? Well, 20, not on my magic list. The 3 stays outside. The 20 is 4 times 5, and 4 is a magic number on my list. And it becomes a 2, but there's already a 3 out there. So somehow this 2 and 3 have to interact. And how do they interact? They end up multiplying. All right, so I got a 6 on the outside because it's 3 times 2. The 5 is not magic, so it stays inside. So it's 6 root 5. That's supposed to be a 5 there. And there's that answer, okay? Now, you can also have negative numbers out there. All right, let's do -7. And now this is -7 times the square root of 90. All right, this is like there's an invisible multiplication there. We don't always say it. It's just like how when we write, like, say 2x. 2x is really 2 times x. We just don't always write the dot. This is the same thing. All right, when they're next to each other, when it's outside, they're being multiplied. Now, if it's outside, it just stays outside. This job is done. Right? 90, what are magic numbers? 90 is not on this list. 100 is, because that's 10 times 10. 90 is not on this list. But 90 is 9 times 10, right? And 9 is a magic number on this list. So it moves out and becomes a 3. But there's already a -7 out there. So they have to interact. If there's a number that moves out and there's already a number outside, they have to connect. And how do they connect? They multiply. So 7 times -7 times 3 is -21 root 10. Now, are there any magic numbers hidden in 10? The only thing that multiply to 5 are 2 and 5. They're not on this list. And 1 and 10, and they're not on this list. So that just stays like that. All right, so that is my final answer. Now, what if I asked you to simplify the square root of 15? Well, the only numbers that multiply to 15 are 5 and 3, or 15 and 1, and are either of these numbers magic? And the answer is no. So if there's no magic numbers, it just stays as it is. Trick question. All right, so that can definitely happen. Okay, now part 2 of this is, what's the difference between square root of 4, negative square root of 4, and square root of -4. We have 3 different situations there, and actually all 3 of these might happen in a quadratic formula. Are they the same thing, or are they different? Okay, well, let's talk about this one. Case 1, we'll call it case 1, case 2, and case 3. Any of them can happen. Case 1, we've already seen. Square root of 4, it's a magic number on my list, becomes 2. So that just equals 2, and we're done, all right? This, All right, now a negative. A negative is, there's a number hidden out there, and I call these hidden numbers ghost numbers because they disappear. And this a negative outside is a ghost, -1. It's a -1 in disguise. And that's why I call it a ghost, because when it's just a 1 or a -1, it disappears and only the negative is left over. All right, so that's like a -1 times 4. And just like before, 4 is a magic number. It turns into a 2, but there's already a negative outside. So the answer to that one is -1 times 2, which is -2. So notice these two are not the same thing, all right? So let's kind of separate these so I can kind of see. Now, what about case 3? All right, well, if you're doing a square root, remember what square roots mean. We've been kind of taking some shortcuts with the magic numbers because that allows us to take some shortcuts. But this is a little bit different, right? When you're taking a square root, you're asking what two numbers can you multiply to get the number inside. The reason this worked is because 2 times 2 does get us 4. So that's why you just take one of them and that's your answer, okay? So we have to ask ourselves what two numbers that are alike would multiply together and get -4. What two numbers? And they have to be the same number. Now most people will guess -2. All right, but let's think about this. -2 times -2, when you multiply two negatives, they cancel and become +2, so that doesn't work. When you multiply two -2s, you don't get -4, you get a +4, so that doesn't work. So you still gotta find two numbers that when you multiply them, you get -4. Now the other guess is, well, let's just do a -2 and a +2. Now you're correct, that is -4, but the catch is they have to be the same number. And +2 and -2 are not the same. They're not the same. So that doesn't count either. So is there an answer? And actually there isn't. There's no solution to this, right? This actually gets dealt with extensively in your Algebra 2 class, but for right now, you would just stop and say this problem has no solution. So it does make a big difference. If the negative is on the inside of the square root, it's no solution. If the negative is on the outside of the square root, it's just a ghost -1, and that's perfectly fine. So these three situations are not the same thing. So just treat them carefully, okay? All right, and there's your quick little simplifying square roots review. Hope it was helpful.